February 20, 1943, north of the Kasserine Pass, Tunisia. The official battle reports could never capture what German tank commanders saw that morning. American Sherman tanks moving with coordination that defied everything Wehrmacht doctrine claimed was possible without visual signals. Through the swirling dust and smoke of the North African battlefield, 5 Shermans, scattered across broken terrain and completely out of sight from one another, converged on German positions with timing that felt uncanny. No signal flags, no flares, no motorcycle couriers racing between vehicles. And yet, they maneuvered as if connected, each tank instinctively covering the blind spots the others could not. Each crew seemingly aware of where their comrades were without ever laying eyes on them. Inside their Panzer IVs, fitted with 4-5 radios, German commanders struggled to hear even their own leaders. Static and interference overwhelmed the amplitude modulation sets. Those 10-watt transmitters, considered advanced in the 1930s, barely carried a few hundred meters when the tanks were in motion. Most German vehicles carried only receivers, unable to transmit reports or call for support. The Americans were operating on a different plane, using technology the Germans hadn't even realized existed. Every Sherman carried a frequency modulation radio, crystal-controlled, delivering 25 watts of power with voices cutting cleanly through the roar of engines and chaos of combat. 8,000 miles from Detroit's assembly lines, the most decisive technological advantage of the war was making itself known, not in armor thickness or gun caliber, but in the invisible radio waves binding American tank crews together in ways the Wehrmacht had never imagined. That transformation had begun on July 2, 1941, when the U.S. Army standardized the Signal Corps radio sets SCR 508, 528 and SCR 538 for medium tanks. While German forces pushed deep into the Soviet Union relying on limited AM systems, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting FM sets that would make German radios obsolete. Among them was Daniel E. Noble, who first envisioned FM for armored warfare, and Henryk Magnuski, the lead RF engineer who solved the challenge of installing delicate electronics inside a tank. Their creation weighed 181 pounds and turned every Sherman into a node of the world's first true battlefield network. The BC-6 and 4 transmitter produced 25 watts of power, 2.5 times the FUG-5. Operating in the 20 to 27.9 meters range, it offered 10 preset crystal-controlled channels. Dual BC-63 receivers in the SCR 508 let commanders monitor multiple frequencies at once, a capability German crews couldn't match. But the real revolution was frequency modulation itself. Edwin Armstrong's FM system, licensed for military use, eliminated the static and interference that plagued AM radios. Where German sets picked up every spark plug and electric motor as noise, American FM sets carried clear, steady voices, even under artillery bombardment. When Operation Torch began on November 8, 1942, armor rolled into North Africa with this hidden advantage. The 2nd Armoured Division landed at Safi and Fadala with SCR 508 radios that soon proved superior. The vaunted Afrika Korps, the Wehrmacht's most experienced armoured force, was crippled by its communication limits. In a standard German platoon of 5 tanks, only 1 or 2 carried full FUG-5 transceivers. The rest had FUG-2 receivers only, able to hear orders, but unable to respond or report enemy positions. Coordination depended on rigid hierarchy, and when command tanks, easily identified by their extra antennas, were destroyed, entire platoons fell into chaos. Against Americans, where every tank could assume command, this weakness was fatal. The Battle of Kasserine Pass, February 14-24, 1943, gave the first major test of these systems. Though a tactical German victory, the fight stunned Wehrmacht observers. Amid confusion, scattered elements of the U.S. 1st Armoured Division stayed coordinated across nearly 50 miles. Crews who had never met in person shared attack plans, warned of ambushes, and called in artillery with crystal, clear transmissions. German signal units, intercepting U.S. traffic, noted with alarm the range, clarity, and coordination their own radios could not achieve. More troubling still was the realization that nearly every American tank carried a full transceiver. By contrast, German FUG-5 sets operating on AM between 27.0 and 33.3 Mach struggled to reach even 2 kilometers in ideal conditions, and often less than a few hundred meters when moving. Every engine spark, every electrical discharge, drowned them in noise. In September 1943, as American tanks advanced into Italy, the mountainous terrain should have cancelled out radio advantages. Instead, FM proved even more powerful. Handling echoes and multipath interference that crippled AM, U.S. armor coordinated through valleys and ridgelines where German radios failed entirely. Platoons separated by mountains attacked in unison, a feat German doctrine insisted was impossible without visual contact. After-action reports from the 1st Armoured Division described seamless coordination at distances where German crews heard only static. By June 6, 1944, Sherman tanks rolling ashore at Normandy used their SCR-508s to call directly to naval fire support, a level of coordination no German tank could match. Yet the hedgerow fighting exposed a flaw. Tank radios operated on 20-28 Mets, while infantry SCR-300 sets worked at 40-48 Mets. Unable to communicate, American infantry could not always warn tanks of lurking Panzerfaust teams. Losses mounted until crews improvised. They mounted EE-8 field telephones in ammunition boxes welded to the outside of their tanks, wired into the intercom. By Operation Cobra in July, infantry could simply pick up a handset and talk directly to the tank crew. Operation Cobra, July 20-30, 1944, revealed the full force of America's radio advantage. Major General Edward H. Brooks commanded over 200 Shermans through a seamless network. German defenders of Panzer Division faced an enemy that seemed almost omniscient. U.S. tanks reacted instantly to threats reported by other units miles away, and artillery fire landed within minutes of a call. The contrast was stark. Panzer, once the elite of German armour, was reduced to communication poverty. Most of its tanks lacked transmitters entirely, signalling only by flags or hand gestures in terrain where visibility rarely exceeded 100 meters. The irony was bitter. Germany had pioneered tank radios. Heinz Guderian, the father of Blitzkrieg, had demanded every tank carry a set as early as the 1920s. His 1937 book Achtung Panzer emphasized communication as the foundation of armored warfare. He knew speed and shock required constant coordination. Yet by 1943, German industry could not build enough radios to meet his own doctrine. Production numbers tell the story. In 1943, Germany built roughly 700 medium tanks, but fewer than 2,000 full transceivers. Most went to command vehicles, leaving regular crews deaf and mute. By comparison, every Sherman carried a powerful FM set, turning American armor into something new, a connected, cooperative force. And while the Soviets suffered even worse shortages, the Americans had built the first battlefield network. In Africa, in Italy, in Normandy, the invisible voice inside every Sherman would prove as decisive as its armor or gun. The T-34, despite being the most produced Allied tank of the war, usually entered combat without radios. Soviet doctrine relied on flag signals and pre-battle planning, a method that proved disastrous against the Germans in 1941. By 1943, Lend-Lease shipments began to ease the shortage. American SCR-508 sets equipped some Soviet command tanks, but even by the war's end, only about 25% of Red Army tanks carried radios. The contrast highlighted America's achievement. While the Soviet Union struggled to outfit a quarter of its armored force with any form of communications, the United States achieved universal deployment. Every single Sherman carried an advanced FM set. This accomplishment was a testament to American industry. Motorola's Chicago factory, which before the war built car radios, had to be completely retooled for military production. Each SCR-5 required 248 individual parts, all built to demanding tolerances. The BC-64 transmitter alone contained 474 capacitors and 385 resistors. Its crystal oscillators had to remain stable despite battlefield vibration and extreme temperatures. Production of the story. In 1942, 3800 SSER 508 family sets rolled off the lines. In 1943, 11400 more. In 1944, nearly 24,000. By war's end, more than 50,000 tank radios had been produced, enough to equip all 49 324 Shermans ever built. No other nation came close. The SCR-508's advantages extended well beyond frequency modulation. Its crystal-controlled stability meant channels could be preset before battle and hold alignment throughout combat. German Fugue 5 sets, using variable capacitor tuning, constantly drifted off frequency. American dual receiver configurations let tank commanders monitor both platoon and company nets at the same time. Orders flowed instantly while commanders remained aware of subordinate situations. Inside the tank, the BC-6 and 6 intercom tied everything together. Throat microphones and noise-cancelling headsets allowed crew members to report threats clearly in the middle of combat. Many German tanks lacked intercoms altogether, leaving their crews to shout or rely on physical signals. Power management was another advantage. The SCR-508 worked on either 12 or 24 volts, automatically adjusting to whatever the vehicle provided. A dynamotor supply delivered clean, filtered power that suppressed interference. By contrast, German radios fed directly from tank electrical systems picked up every spark as static. This universal communications capability transformed American armor doctrine. The flexible, combat command, structure task forces tailored for each mission, was possible only because reliable radios tied together disparate units. German commanders, bound to rigid structures by limited communication, were baffled by the Americans' fluid organization. At the Battle of Aracourt in September 1944, the U.S. 4th Armored Division faced multiple Panzer brigades with superior Panther tanks. On paper, the Germans held every technical advantage, yet American coordination proved decisive. Every Sherman reported enemy movements instantly. Tank destroyers were directed toward targets they couldn't see. Artillery observers riding in command tanks called in barrages within minutes. Over 3 weeks, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 ratio that defied technical specifications. Throughout the war, German intelligence consistently misunderstood this edge. Reports noted American coordination but attributed it to discipline and training rather than technology. A captured assessment from September 1944 concluded, American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid procedures. The analysis completely overlooked the decisive role of FM sets. German tactics never adjusted. Command tanks were singled out based on antenna configurations, not realizing that every Sherman could take command. Ambushes were planned under the assumption that separating American tanks would break their cohesion, never grasping that radio links kept U.S. units synchronized even when scattered. By March 1945, as American forces approached the Rhine, this superiority reached its peak. The capture of the Ludendorff Bridge at Remagen was a case in point. When the 9th Armored Division discovered the bridge intact, word traveled by radio to 1st Army headquarters within minutes. Within an hour, entire divisions were shifting to exploit the opportunity. German defenders, reliant on telephone lines already shredded by Allied aircraft, could not respond with anything close to comparable speed. At Remagen, American radio networks allowed platoons from different battalions to integrate seamlessly. Fires were coordinated instantly, while German counterattacks arrived piecemeal, disorganized, and easily destroyed. April 1945 brought the encirclement of the Ruhr Pocket, the final demonstration of American communication supremacy. The 1st and 9th Armies executed a massive double envelopment coordinated almost entirely over radio nets. Inside, 325,000 German troops were trapped, cut off as Allied fighter bombers, guided by radio-equipped forward controllers, systematically destroyed German communication hubs. Wehrmacht units lost contact with higher headquarters and with one another. Field Marshal Walter Model's last messages spoke of isolation, no contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. For American crews, the psychological difference was profound. Even when cut off physically, they were never truly alone. Radio waves kept them connected to their comrades. German tankers experienced the reverse isolation. Without radios, they fought blind, each engagement an individual struggle within a larger battle. Otto Carius, one of Germany's most successful tank commanders, would later describe in Tigers in the Mud the frustration of fighting under such limitations, though he emphasized tactics rather than the deeper communications gap. Strategically, the implications were enormous. From 1944 into 1945, the speed of American advances across Europe depended as much on radio coordination as on fuel or firepower. The Third Army's dash across France was made possible by networks that kept units synchronized across hundreds of miles. German commanders consistently underestimated this advantage, unable to imagine the scale of American communications superiority. Even Heinz Guderian, the architect of Blitzkrieg, recognized the crisis. As Inspector General of Armored Troops, he warned in late 1944 that American radios negated German advantages in tank design. But nothing could close the gap. After the surrender, U.S. technical intelligence teams evaluated captured German equipment. Their verdict confirmed what battlefield experience had already proven: German armor was formidable in guns and armor, but catastrophically inferior in communications. Report No. 176 concluded German systems were at least 5 years behind U.S. technology. The lack of frequency modulation, the shortage of radios, and poor electrical suppression had created vulnerabilities the Wehrmacht never overcame.